Hello friends. This video is brought to you by mywayteaching.com.
Here we shall discuss how to calculate volume of solids made up of combination of two basic solids. Here we will see that volume of the solid formed by joining two basic solids will actually be the sum of the volumes of the constituents. Let us consider this example. Shanta runs an industry in a shed which is in shape of a cuboid surmounted by a half cylinder as shown in this figure. If the base of the shed is of the dimension 7 meter by 15 meter and the height of the cuboid is 8 meters, find the volume of the air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter cube and there are 20 workers, each of whom occupy 0.8 meter cube space. Then how much air is in the shed? Now clearly the volume of air inside the shed, when there are no people or machinery inside, will be given by volume of the air inside this cuboid and inside half the cylinder which is surmounting it. Recall the formula for volume of a cuboid is length into breadth into height plus half volume of the cylinder is given by pi r square h. Clearly, radius of the cylinder will be 7 by 2. Let us substitute the values. We have length as 15 meters, breadth as 7 meters and height is 8 meters plus half of pi into 7 by 2 whole square into height, which will be given by 15. This gives us the volume. Taking pi to be 22 by 7 and solving further, we get 840 plus 288.75, which is equal to 1128.75 meter cube. So, volume of the empty shed is 1128.75 meter cubes. Now let us calculate the volume occupied by the machine and 20 men, which will be given by 300 meter cubes plus 20 into 0.08 meter cubes, which is equal to 300 plus 1.6 meter cube. The volume occupied by machine and 20 men is 301.6 meter cubes. Now we can easily find the volume of air when there are machines and worker inside this shed, which will be given by volume of the empty shed minus volume occupied by machine and 20 people. So this amounts to 827.15 meter cube. Hence we have volume of the air that the shed can hold is 1128.75 meter cubes and volume of the air that the shed can hold when there are machines and worker inside is 827.15 meter cube. Let us read the question. A juice seller was serving his customer using glasses as shown in this figure. The inner diameter of the cylindrical glass was 5 centimeters, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of the glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. Here, apparent capacity means the capacity of the glass which the customer is judging that he is buying, which shall be given by volume of the cylindrical glass, that is pi r square h. We take pi as 3.14. Radius will be 5 by 2, that is 2.5 whole square, and height is 10 centimeters. So our apparent capacity or the volume is equal to 196.25 centimeter cube. But actually the glass has lower capacity as there is a hemisphere at the base of the glass. So actual capacity of this glass is the apparent capacity minus volume of this hemisphere. So we have the following expression: 196.25 centimeter cube minus 2 by 3 pi r cube centimeter cube, because volume of the hemisphere is 2 by 3 pi r cube. Let us substitute the values. We get 2 by 3 into 3.14 into 2.5 whole cube This will give us volume of the hemisphere is 32.71 centimeter cube, and hence the actual capacity of the glass is 163.54 centimeter cube. Let us read the question. A solid toy is in form of a hemisphere which is surmounted by a right circular cone. The height of the cone is 2 centimeters and diameter of the base is 4 centimeters. Determine the volume of the toy if a right circular cylinder circumscribes this toy. Take pi equal to 3.14. From this figure, clearly radius of the hemisphere, that is BO, will be 4 by 2 centimeters. So the radius is 2 centimeters, which is also the radius of right circular cone and the right circular cylinder which is surmounting the toy. Now let us calculate volume of this toy, which is equal to volume of the hemisphere plus volume of the cone. Let us recall the formulas. Volume of the hemisphere is 2 by 3 pi r cube plus volume of the cone is 1 by 3 pi r square h. Height is also given to us, so not a problem. Let us substitute the values. We have 2 by 3 into 3.14, which is the value of pi, into 2 cube plus 1 by 3 into 3.14 into 2 square into height, which is 2 centimeter cube. Solving this further, we get volume of the toy equal to 25.12 centimeter cube. According to the question, we are also required to find the difference of the volume of the cylinder that is surmounting the toy and the toy itself. That means we need to calculate volume of the right circular cylinder and subtract this volume from that. For that, we would need the height of the cylinder EFGH. Clearly, this height will be AO plus OP, and OP is the radius of this hemisphere. So the height will be AO, which is 2 centimeters, plus OP, which is also 2 centimeters, implying that height of the cylinder is 4 centimeters. Now we can find volume of the cylinder. Just substitute in the formula. We have 3.14 into 2 square, as radius is 2, into height, which is 4, which is equal to 50.24 centimeter cube. Now we can easily find required volume equal to volume of the cylinder minus volume of the toy, that is 50.24 centimeter cube minus 25.12 centimeter cube, which is equal to 25.12 centimeter cube. Hence, the required difference of the two volumes is 25.12 centimeter cube.